Imagine a tiny silent explorer, a lone sentinel launched from Earth, drifting endlessly through the inky blackness, the profound darkness between the stars. It's a journey measured not in miles, but in light years. It's a relic of human ingenuity, a testament to our boundless curiosity and our relentless pursuit of the unknown. Carrying a golden record, a time capsule filled with the sights and sounds of Earth, a message in a bottle cast into the cosmic ocean. For decades, its cameras have been shut, their lenses closed to the vastness around them, conserving every last bit of energy, husbanding its resources for a journey that stretches far beyond our reach into the interstellar void. But what if, against all odds, we could send a command, a signal piercing the cosmic static? Across billions of miles of empty space, a desperate plea echoing through the void. What if we could ask it, after all this time, to open its eyes one last time? What would it see in that alien starlit canvas? What secrets would it reveal from the edge of our solar system? The Voyager spacecraft, Voyager 1 and 2, are more than just machines. They are our silent emissaries, our robotic ambassadors to the cosmos, pushing relentlessly against the boundaries of exploration, venturing into the unknown where no human-made object has gone before. The idea of reactivating their cameras, even hypothetically, in 2025, sparks the imagination. It's a powerful thought experiment, a cosmic what-if that forces us to confront our place in the universe, forcing us to confront the sheer, incomprehensible scale of the universe, the distances that dwarf our earthly concerns, and to truly understand our place, our fragile existence, within it all. To receive a new image, a single photon captured by Voyager and transmitted across the gulf would be like getting a postcard, a snapshot from the very edge of the solar system, a place we can only dream of reaching. It would be a technological miracle, a testament to human ingenuity, and a profound human connection to the vast cosmos. So, let's embark on this journey together, a journey of imagination and scientific exploration, to explore Voyager's incredible history, from its launch in 1977 to its current lonely voyage. We'll delve into the reasons its vision was dimmed, the difficult choices made to conserve precious power, and we'll examine the immense engineering challenges, the almost insurmountable obstacles of restoring its sight. The cosmos is waiting, and Voyager may yet have one last glimpse to share. Our story begins in 1977, when a rare planetary alignment offered a unique opportunity. NASA launched Voyager 2, then Voyager 1, to tour the gas giants, using gravity to slingshot from planet to planet. These probes revealed Jupiter, Saturn, Uranus, and Neptune in breathtaking detail, serving as our robotic eyes in the outer solar system. Each carried the golden record, a message in a bottle filled with sounds and images of Earth sent into the cosmic ocean. After their planetary flybys, the Voyager's mission was just beginning. Powered by decaying plutonium, they sped beyond the Sun into unexplored territory. Today, Voyager 1 is over 15 billion miles away. Voyager 2 follows on a different path. They are the farthest human-made objects, having crossed into interstellar space. The Voyagers continue to send back data, rewriting our understanding of the galaxy. They are no longer just planetary explorers. They are our first interstellar pioneers. On Valentine's Day, 1990, Voyager 1 turned back for a final look, capturing the iconic family portrait, including the pale blue dot. This was the last act for Voyager's cameras, which were soon powered down. The reason? Power. The spacecraft's nuclear batteries produce less energy each year, so engineers prioritized vital instruments over the cameras. In interstellar space, there's nothing nearby to photograph. Just distant stars, too faint for the camera's design. The cameras had fulfilled their purpose. Keeping them running would waste precious power. Their software was also turned off, freeing memory for new scientific programs. Voyager had to evolve, trading its photographer's eye for the role of interstellar scout. The pale blue dot was a fitting farewell, a profound statement on our place in the cosmos. It marked the end of one chapter and the beginning of another. Turning Voyager's cameras back on is a dream fraught with challenges. Power is the first hurdle after nearly 50 years. The spacecraft's energy is critically low. Diverting power to the cameras could end the mission entirely. The hardware is ancient 1970s analog cameras, dormant for decades in the freezing vacuum of space. There's no guarantee the moving parts or electronics would even work. The software is another obstacle written in obsolete languages, with the original engineers long gone. Recreating the software environment would be a massive undertaking. Communication is painfully slow. A round-trip signal takes nearly 2 days. Every command would be a high-stakes gamble, with no room for error. Waking Voyager's cameras is a beautiful idea, but perhaps best left to imagination. Suppose, against all odds, after decades of silent drifting, Voyager's camera flickers back to life, its long-dormant sensors awakening in the inky black. Imagine the power surging through its circuits, preparing to capture an image unlike any other. What would it see as it gazes out into the interstellar void? What secrets would the universe reveal to this resurrected eye? Darkness, an immense, perfect blackness, a profound absence of light that stretches out in every direction, seemingly without end. Untainted by any atmosphere. No scattering, no diffusion, just pure, unadulterated darkness. Against this void, stars would shine with unnerving clarity. Sharp, steady, brilliant points of light, burning with an intensity unseen from within any planetary atmosphere. Familiar constellations would appear subtly distorted, seen from a new, distant perspective, their familiar shapes skewed by the vast distances traversed. The galactic plane would stretch across the frame, a river of light, denser and more detailed than any earthly view, a swirling panorama of billions of stars. Dark lanes of interstellar dust would wind through the galaxy's spiral arms, obscuring and revealing the starlight in a cosmic dance of shadow and light. The chance of capturing a rogue planet or asteroid is virtually zero. Interstellar space is defined by its emptiness, a testament to the sheer scale of the cosmos. The view would be one of majestic stillness, a portrait of the universe in its default state, undisturbed and serene. The photograph would not be of a thing, but of a place. The great silent sea between the stars, the vast expanse that separates us from other worlds. It would be a perspective astronomers have only dreamed of, a vantage point beyond the confines of our solar system, a picture of cosmic solitude, a reminder of our place in the grand scheme of the universe. Among all possible targets, one holds special power, our sun and its planets. From over 15 billion miles away, the sun would be just another star, still the brightest, but a mere point of light. Earth? Nearly invisible. In 1990, it was a single pixel. Now it would be a ghostly glimmer, lost in the camera's noise. The inner planets would blur together, indistinguishable from one another. We would not be a pale blue dot, but a faint, fuzzy speck, if visible at all. This view would be the ultimate illustration of our cosmic isolation. To see our world reduced to an invisible mote is humbling, a silent testament to our fragility. It's a reminder of the immense journey we've undertaken and the even longer one ahead. If the image would be mostly blackness, a canvas dominated by the absence of light, why does it matter? Why dedicate resources and effort to capture something that appears to be nothing? The answer, in its simplest form, is inspiration. The pale blue dot's power was philosophical. It wasn't about scientific data, but about perspective. It fundamentally changed our perspective, forcing us to reconsider our place in the cosmos. A new image from Voyager, even if seemingly empty, would do the same for a new generation, sparking their imagination and curiosity. It would be a shared experience, uniting people around the globe in a collective moment of reflection. It would spark conversations, igniting discussions about our existence and the vastness of space. Inspire curiosity, pushing us to ask questions about the universe and our role within it, and remind us of our shared identity as Earthlings, bound together by our common home. The value wouldn't be measured in pixels or technical specifications, but in the wonder it inspires. It would symbolize persistence, a testament to human determination. Voyager is a monument to long-term thinking, a project that transcends generations. Built by one generation, with a vision for the future, managed by another, carrying the torch of exploration forward, and still journeying on, a silent ambassador carrying our message to the stars. Reactivating the cameras would connect past and present, bridging the gap between the pioneers of space exploration and the dreamers of today. celebrating human curiosity and our drive to explore, the very essence of what makes us human. A new image would update our sense of scale, providing a stark reminder of our cosmic address. A pale blue speck, almost invisible against the backdrop of infinity, or perhaps a pale blue nothing, a humbling perspective indeed. It would be a humbling reminder, a cosmic perspective check, that the universe does not revolve around us, that we are but a tiny part of something incomprehensibly vast. In that humility, in recognizing our smallness, we might find a renewed sense of responsibility for our fragile world, our only home in this vast cosmos. Is there any new science to gain from a Voyager image? Modern telescopes surpass Voyager's cameras, but its unique location offers rare opportunities. Parallax measurements from Voyager and Earth could refine stellar distances, improving our understanding of the galaxy. Voyager's view of the Sun, outside the zodiacal dust, could provide a clearer measurement of its brightness. Looking back, Voyager could map interplanetary dust in ways impossible from Earth. Even a mostly dark image would measure the background light of interstellar space, a crucial data point for cosmologists. It would be the cleanest image of the deep universe ever taken, a small but meaningful scientific legacy. Voyager won't last forever. Soon its power will fade and its signal will cease. It will become a true ghost ship, drifting for millions of years, carrying its golden record. The dream of one last photograph is a race against this silence, a final gesture of exploration. The act itself would be a bookend to the pale blue dot, a last look at home before venturing into the eternal night. Voyager's legacy is secure. It transformed our understanding of the solar system and inspired generations. But one final image would add an emotional capstone, a gift from the past to the future. We may never see through Voyager's eyes again. The hurdles are immense. Yet, the very act of imagining that view keeps the spirit of exploration alive. It invites us to contemplate the vast, magnificent cosmos we are part of. What would that final postcard say? Perhaps, "Wish you were here."